the particular project that I want to talk about. I ran this project at Telstra Health. Telstra Health, as you may or may not know, is a large healthcare organisation in Australia. It's a wholly owned subsidiary of Telstra. And when I joined in 2015, they were awarded the running of the National Cancer Screening Register, which meant that they set up, and that was my role, to set up the infrastructure, the application, all of the security, all of that sort of stuff. So essentially the running model for the National Cancer Screening Register for both cervical cancers and bowel cancers. As a part of that register, we received reports from pathologists. And I'm looking at one on the screen here on the right-hand side. This is a histopathology report. And probably, again, preaching to the choir, but for the purposes of the video, histopathology is where a histopathologist looks down a microscope at cells and writes a report on what he or she sees down that microscope. The key thing about this is that there is no standard format for these. It is largely free text. We do receive them electronically, and that's an HL7 report there, and the free text, the FT field on the HL7. But the format of it, and I've deliberately chosen a small one there so it would fit on the screen, but these can go for pages, absolutely up to the pathologist. The language, the headings, all of those sorts of things, completely up to the pathologist in what they choose to do. Some interesting things there from a data point of view, and looking at that. Cervical biopsy, I'm reading from the clinical notes there, CXBX stands for cervical biopsy at 9 o'clock. Look at the way that's been formatted. How do you do data validation, rules-based validation on nonsense like that you're receiving? And this is just a small example. So what's essentially the problem? Well, these come in, as I said, electronically, and they are manually coded. In other words, there is a coder. You know what coders are. They sit there and they read these reports, and they determine a diagnosis code, ICD-10 coding or SNOMED coding, whatever it is that we've deemed to be used, and they will apply the appropriate diagnosis code to this. We were, at the time, receiving around about 17,500, almost 20,000 reports per month, which roughly equates to around about 1,000 a day of these. The coders, at peak speed, fully trained, could do about 65 of these a day. So essentially takes them about an hour. So that included the validation. So one coder would code it, second coder would come in and validate. So the entire, from receiving a report to actually validated diagnosis code, we were doing 65 per day. Now, coders cost roughly around about 150K each. And you can do the maths there, and you can work out that it was roughly costing us around about $2.4 million a year in coders just to keep up. Now, when we took on the register, there was a huge backlog, huge. I'm talking hundreds of thousands of reports that needed to be coded. So costing us $2.4 million just to keep up. The business case for this was actually quite extraordinary. It was going to pay back in less than 9 months in terms of if we could get it working. We entered into a co-development partnership with IBM and started the project. So, was this project successful? The original target was above 90%. Absolutely achieved that, knocked it out of the park. Very, very clearly out of the park. I learned that accuracy was an ill-defined concept. I took many discussions and took people through this. It's not actually an ill-defined concept. It is very well defined. It was ill understood, or not very well understood, in our organization about what accuracy was. And we had different measurements. This led to a disagreement on what the goalposts were. And I will say that as at this date, this project hasn't gone into production. It's sitting there ready to go into production. It hasn't gone in yet. Why did I start and introduce to you a project which by normal measures, i.e. it hasn't gone into production yet, it's not saving any money, it's not a successful project. I did it because the technology succeeded. The technology was an absolute outstanding success by any measure. The speed, accuracy, volume, all of those sorts of things. Really, clinical safety, everything. But there were some key things that we neglected to do along the way, and that brings out some really good learnings for us. So get your organization ready for an AI project. The first one there I've got, have a project governance framework. Well, actually, if you look along there, not too many of these are unique and new things for AI projects. And that's my big underlying thing is don't treat AI projects too differently to any others. So have a good project governance framework. Example, Agile. Agile is really useful in this one. Have a data governance policy, because AI, machine learning, all of this requires a large amount of data, and having in place data governance. Where do you collect the data? Where do you store it? How is it going to be used? All of those sorts of things already in place, and they will underpin your project. Security policies in place. What about applications in the cloud, sending data off-site, sending clinical data into the cloud? Where is that cloud? Is it within Australia? Is it overseas? A lot of our healthcare requirements are that the data remain within the sovereign borders of the country we're operating in. So having a security policy coupled tightly with your data governance is necessary, not just a good thing. We also, this is the new one, make sure you've got an AI governance and ethical use policy. The field is changing so fast that you're not going to be able to get too specific in this policy, but laying down some principles, some guidelines, some guardrails, as it were, for your project to say, as an organization, this is what we will do with AI, but this is what we won't do. We won't do these things. And in healthcare, one of the key ones that came across, and in Telstra Health, we developed this policy. We're not going to build self-learning, autonomous AI clinical decision machines. They need to be explainable. They need to be controlled and trained in an appropriate environment. So having those guardrails is very important. And they're engaging with your clinical safety committee.